Hello and welcome to another lecture on power electronics. Today we'll be looking at power flow in switch mode power converters. If you recall from my last lecture, we saw this basic architecture of a variable frequency drive system. The AC mains, which is converted into a DC voltage, which appears across a capacitor here. And this inverter then converts this DC voltage into a variable frequency and voltage AC, which is then fed to an inductive load such as an induction machine. Now, we also saw that power flow can be reversed. That is, during regenerative braking of the motor, power can be recovered and fed back to the grid. And this operation of the switch mode converter is known as the rectifying operation, where power is converted from the AC to the DC side. So let's assume that the power here on the DC side is Vd times Id, and on the AC side the power is I naught times V naught. Now, since the load is inductive most of the time, we can assume that the current lags the voltage. So if I write it in phasor notation, I can write that V is equal to V angle 0, and current then lags this voltage by an angle theta, which can be represented on an arcgand diagram like this. That is, if the phasor of the voltage is this one, V, then the current would lag this voltage phasor by an angle theta. So now let's look at the direction of this power flow. So here I have plotted two signals. This is the voltage signal V naught, which starts at 0, and the red one is a current signal which lags the voltage by an angle theta. So it starts after a delay of theta. So this is a lagging current waveform. Now we want to see the direction of the power flow. Since power is V naught times I naught, we can see from this figure that during this region, let me call this region 1, V naught is positive and I naught is negative. So the power flow in this region, P naught, is negative. Similarly, in region number 3, let's call this region 3, the current I naught is positive while the voltage V naught is negative, and hence the power flow P naught is again negative in this region. Both V naught and I naught are positive, and hence the power flow is positive. While in region number 4, from here to this point, in this region both I naught and V naught are negative, and hence the power flow again becomes positive. So what does this positive and negative power flow mean? The positive power flow means that the power is flowing from the DC side to the AC side during this second and fourth region, while in the first and the third region the power is flowing from the DC side to the AC side. So this is region number 1 and 3. So in other words, these two regions are the rectifying mode of operation, while region 2 and 4 are the inverting modes of operation. So this can also be represented in the Cartesian plane. So we have 4 quadrants: first, second, third, and fourth. Let me call this V naught and this as I naught. When both I naught and V naught are positive, or both I naught and V naught are negative, we have the inverting mode of operation. While when one of them is negative, that is V naught is negative here and I naught is positive, then this would be the rectifying mode of operation, as well as in quadrant number 4 when I naught is negative and V naught is positive. So that's it for today's lecture. I just wanted to give an overview of the power flow in switch mode power converters. And in our next lecture, we'll start with single phase inverters. So see you in the next lecture.